So that's the clinical significance. And we'll delve now into the physiological mechanisms of sleep regularity. Now, as you know, the circadian rhythm represents our intrinsic natural rhythm of our body. This rhythm helps to determine the optimal timing of various physiological processes. For instance, deep sleep tends to happen in the early morning, approximately 2 a.m. And this is like an ideal example. Our lowest body temperature tends to happen around 4:30 in the morning. Our cortisol peaks around 7 a.m. Our alertness peaks at around 10 a.m. We have the highest coordination and reaction time at around 3:30 in the afternoon. Our highest strength is around 5 p.m., highest blood pressure around 6:30. Melatonin starts to rise at around 9 p.m. And so you have this inherent natural rhythm that occurs for us. And this happens through a rich, diverse integration between the central master clock, which is in the suprachiasmatic nucleus, and the various peripheral clocks located in key organ systems of the body. This includes muscle, heart, kidney, lungs, adipose tissue, and liver. And so it makes a lot of sense for us to have our behaviors act in cooperation with this ingrained natural rhythm. And so when I'm talking about behaviors, I'm talking about sleep, exposures to light, physical activity, eating and fasting periods. And ideally, by integrating or coordinating our behaviors so that it matches our circadian rhythms, we're enhancing our circadian integrity. And we're ensuring that our internal rhythms are acting in alignment with our external behaviors, and the body is thus able to function optimally. Now, what happens though if you're not acting in alignment with your natural rhythm? You're doing things like sleeping at odd hours or exposing your light in the middle of the night or eating in the middle of the night. What happens is that subsequently it leads to continuation of the internal circadian rhythm. This in turn leads to impairment of your circadian behaviors. And so your behaviors can become erratic, and then this feeds back even further to subsequently attenuate the natural rhythms. So it becomes a feedback loop. Core behavior leads to poor internal rhythms and natural rhythms, which leads to even further worsened irregular behaviors. And this feedback loop continues to develop until you develop what's called circadian disruption. And this is all the animal and basic science studies that have been shown out there demonstrating a link between circadian disruption and multiple physiological processes. It causes hormonal imbalance, inflammation, gut dysbiosis, increased oxidative stress, endothelial dysfunction. There are multiple physiological effects arising from circadian disruption. The other thing to note is this amplitude of this natural rhythm is important. And this was a study that was done by Dan Windred and Andrew Phillips' group again in 2024 in the scientific report. And this studied 23 individuals and they assessed the amplitude and rhythmicity of the core body temperature along with a number of blood plasma metabolites. And they categorized individuals according to the amplitude of their core temperature rhythm. So if the core temperature had a small amplitude, they were categorized as low. If it's intermediate, then here in gray. And then high had, significant fluctuations in this amplitude. So they placed this in sort of order. So participants with increasing temperature amplitude would be placed on the highest part of this y-axis. And then they also measured metabolites according on the x-axis. So this is the rhythmicities of the metabolites. And you could see that those individuals with high core body temperature had in general more increased rhythmicity across the metabolites that were measured. And this relationship was statistically significant that, the amplitude of the core body temperature correlated with a number of rhythmic metabolites. And it also showed up in the standard deviation of the metabolic period. So in this individual who had a low core body temperature amplitude, you can imagine this person having this red profile here would have sort of a period of the metabolite rhythmicity not really having a specific inherent rhythm, whereas this person with the significantly high amplitude would show a significant period following a natural rhythm. So the amplitude of the circadian rhythm is important to make sure that the peripheral clocks are similarly operating in synchronization. And so, why sleep in particular, as compared to light or meal or exercise, is why is this such a strong predictor? I actually took this from Dr. Dorothy Fisher's YouTube talk. I want to give her credit for this. And the reason for this is that, sleep plays such a central role and it serves as a very natural proxy for variability in other rhythms like meal and exercise. And so the irregularity in sleep, in some ways, also reflects the irregularity in other things that we do during the day. And so sleep irregularity has become such a strong predictor. So I hope that addresses a little bit of the physiological mechanisms.